All right, let's start. In this video, we will be going over section 1.3. This section is about delta-epsilon proofs. Basically, we are going to give an algebraic proof for the limit. This is an optional section in this course. All right, here is again the notations that we will be using for all. This is the symbol for all. And this is when I write this, that means there exist, okay? All right, here is the algebraic definition of limit, definition 1.10. Let's see what is the algebraic definition of limit. Limit as x approaches to c, f of x is equal to L means that for all epsilon greater than 0, there exists delta greater than 0, such that if absolute value of x minus c, that means the distance between x and c, okay, absolute value of x minus c means the distance between x and c. If the distance between x and c is greater than 0 and less than delta, then the absolute value of f of x minus L should be less than epsilon. If this is the case, this limit statement is true, okay? And by the way, this is the formal definition of limit that we discussed in the previous section. These two definitions are equivalent. Okay, as you can see, the first lines are exactly the same, right? In both definitions, the first lines are exactly the same, only this part is different. These two parts are different, but they mean the same thing. For example, saying this is the exact same thing as saying this. This statement is equivalent to this statement. Okay, so these two definitions are equivalent. Well, next theorem formally states that these two theorems are equivalent this way. Okay, saying this, x is in this punctured interval if and only if absolute value of x minus c is greater than 0 and less than delta. Okay, saying this is the same as saying this. Okay, these two statements are equivalent. Remember again, if and only if means if this is true, then this has to be true, and vice versa. If this is true, then the first one has to be true. Okay, and also these two statements are equivalent. F of x in L minus epsilon comma L plus epsilon, if and only if absolute value of f of x minus L is less than epsilon. Okay, so I will prove one of these parts. The other part is very similar. Okay, all right, how do you prove that? Let's prove the both direction. Okay, if x is in this punctured neighborhood, punctured interval, then you have to show that x minus c, absolute value of x minus c, which is the distance between x and c, has to be greater than 0 and less than delta. How do you prove that? Okay, let's prove the prove the forward direction. If x is in c minus delta comma c union c comma c plus delta, then we will show that the absolute value of x minus c is greater than 0 and less than delta. Okay, that's what we are going to show first. So what do we mean by x is in this punctured interval? First of all, let's draw this punctured interval. This is my punctured interval. Suppose you have a hole at the point C. You have a hole at the point C, and here is your C minus delta. Here is your C plus delta. This is your punctured interval, right? This whole thing, except this middle point. You remove the middle. Okay. Now, if your x is in this punctured neighborhood, punctured interval, then x has to be somewhere here, right? By the way, notice that x is in this punctured interval means x cannot be this point C, because point C is not in that punctured interval, right? So x is somewhere here or somewhere in the left. Okay. So if x is somewhere here, as you can see, this distance, the absolute value of x minus c has to be positive, right? Clearly, from the geometry of this figure, absolute value of x minus c has to be positive. It should be greater than 0. That's because these two, the point x and the point c, they are not equal. Okay, point x belongs to this punctured interval. That means point x is not equal to the point c. So there has to be a distance between them. So the absolute value of x minus c has to be greater than 0. How do you get the other inequality? Well, if your x is in this punctured neighborhood, as you can see, the distance between x and c cannot be more than delta. It should be less than delta because this length is delta. Okay, so if you take any point x somewhere here, anywhere on this half of the interval, this distance is less than, if I take my x to be here, this length is nothing but the absolute value of x minus c. That length is less than delta. It is clear from the geometry. Even if you take your point in the left-hand side, somewhere here, again, this length, that is the absolute value of x minus c, right? That length is again less than delta. Why? Because this whole thing is delta. Okay, so it is, from the geometry, it is clear that this is less than delta. So that means if your x is in this punctured interval, this has to be true. So we got the forward direction. Now let's show the other direction. Okay. What is the other direction? Now we need to show that. Now we need to show that if the distance between x and c is greater than 0 and less than delta, then I want to show that my x is in this punctured neighborhood. Okay. Then x is in this punctured neighborhood. That's what I want to show. All right, how do you show that? Let's start with this statement. Let's explore that statement, okay? So here is what I'm going to do. I'm copying that statement here. The distance between x and c is less than delta. That means I can divide this combined inequality into two pieces of inequalities. X minus c has to, absolute value of x minus c has to be greater than c, and absolute value of x minus c has to be less than delta. What does this mean? Absolute value of x minus c has to be greater than 0 means x cannot be c, right? Because if x is equal to c, this will be 0. C minus c is 0. So how can 0 be greater than 0? So absolute value of x minus c is greater than 0 means x cannot be equal to c. And then what does this mean from your pre-calculus? By definition, the x minus c should be greater than minus delta and less than plus delta, right? That's the definition of this. If you apply the definition of this absolute value inequality, this x minus c has to be between minus delta and plus delta. Let's do a little bit more simplification here. I'm going to add c to every expression in this inequality. Then you get c minus delta. Here you get c plus delta. What does this mean? X is between c minus delta and c plus delta. That means x is in this interval, right? That's what it tells you. C minus delta comma c plus delta. That's what it tells you. But remember, oh, here, pardon me, this should be x cannot be equal to 0, okay? Here there's a typo. This should be x is not equal to 0. Okay? All right. So now here it says x is not equal to 0, and here it says x is in this interval. What does that tell you? These statements together tell you that x has to be in this punctured neighborhood. C minus delta comma c union c comma c plus delta. So we get the other direction. Okay. So if this is true, this has to be true. They are equal. Okay. I will leave the other part as an exercise. Please prove this one. Okay. Let's do an example before we go to the next topic. Here is the example that I want to go over. Find formulas for delta in terms of epsilon for each of the following limit statements. Okay, let's work on this one. And then you have a second part, don't forget that. Then write Delta-Epsilon proofs for each of these limit statements. Okay, first of all, what is the limit statement for this one? The algebraic definition. This means part here, okay. For all epsilon greater than 0, there exists delta greater than 0 such that if x minus 4, the absolute value of x minus 4 greater than 0 and less than 0, less than delta, then the absolute value of 2x plus 1 minus 9 has to be less than epsilon. Notice that here my f of x is 2x plus 1. So I have f of x here, and your L is, if you compare the definition, compare with the definition, your L is, in that case, this number 9, your f of x is this, okay? And of course, your c is 4. Value of c is 4, okay? So this is the definition. So what do we need at the end of the day? We need to find delta in terms of epsilon, such that if the absolute value of x minus 4 is between 0 and delta, then f of x minus L, or 2x plus 1 minus 9, the absolute value of 2x plus 1 minus 9 should be less than epsilon, okay? So to find delta, what we do is we start with this one. This is what we want at the end of the day. So I'm going to simplify that inequality, okay? Let me simplify that inequality. 2x plus 1 minus 9. The absolute value of that would be, by the way, I want this to be less than epsilon, right? Now, if you simplify the absolute value, you get 2x minus 8. Of course, you can write that as x minus 4. 2 times x minus 4, the absolute value of that less than epsilon. That means x minus 4, the absolute value of x minus 4 has to be less than epsilon over 2. If you divide both sides by 2, of course, you can pull this 2 out of the absolute value sign, and then you divide both sides by 2. So that way you get absolute value of x minus 4 less than epsilon over 2. That means if your absolute value of x minus 4 is less than epsilon by 2, then this is true. I just simplified this statement, right? So if this is true, this is true. So I take my delta to be epsilon by 2, okay? So my delta has to be epsilon by 2. If my delta is epsilon by 2, if absolute value of x minus 4 is less than delta and greater than 0, then this has to be true. So in this case, my delta is epsilon by 2, okay? All right, now the next step, how do you give the delta-epsilon proof for this limit state? Well, we start it like this. Again, we need to prove this statement, right? This is what we need to prove. Let me copy this part. So this is what we need to prove. So I'm going to take any given epsilon greater than 0, given epsilon greater than 0, let delta is equal to epsilon by 2. I found my delta in the previous part. Okay, we chose our delta to be epsilon by 2 because we wanted absolute value of x minus to be less than x minus 4 to be less than delta. So here absolute value of x minus 4 is less than epsilon by 2. So we took our delta to be epsilon by 2 because we wanted this inequality at the end of the day. All right, now we proceed with the formal proof. Then if absolute value of x minus 4 greater than 0 and less than epsilon by 2, then we have two x plus 1 minus 9, that is f of x minus L, which is equal to 2 times x minus 4, the absolute value of whole thing. But we know that, first of all, let me pull out this 2, the absolute value of x, 2 times absolute value of x minus 4. But I know that my x minus 4, the absolute value of x minus 4 is less than epsilon by 2. So I can replace this by epsilon by 2 to get a bigger quantity. So this has to be less than 2 times epsilon by 2. This 2 will be cancelled. You get the definition. You get the statement in the definition. This is less than epsilon. That's what exactly I wanted to prove. If this is true, I wanted to prove that the absolute value of 2x plus 1 minus 9 is less than epsilon. So we have it. Okay, that completes the proof. All right, next, let's go to the second part. Let me copy that. Okay. First, let's write the limit statement. Limit statement is, this limit statement means the definition. Let's write the definition. For all epsilon greater than 0, there exists delta greater than 0 such that, I'll write ST for such that, okay? Such that if the absolute value of x minus 2 is greater than 0 and less than delta, then the f of x minus L should be less than epsilon. What is your f of x in this case? This is your f of x, this is your L. Okay, so that means absolute value of x squared minus 4x plus 5 minus 1, this should be less than 1. This is your f of x, okay? Now, if you simplify this, all right, this is the formal statement. Then how do you find the delta in terms of epsilon? Again, we start with this. Oh, this should be epsilon, pardon me. Be less than epsilon. All right, to find delta again, I'm going to simplify this inequality, okay? So let me simplify that inequality. X squared minus 4x plus 4 should be less than epsilon. Now, as you can see, x squared minus 4x plus 4 means x minus 2 whole thing squared. The absolute value of that less than epsilon. Okay. Now, this is same thing as absolute value of x minus 2 squared less than epsilon. I can put this square outside. So now if you take both of these numbers are positive numbers, this number and this number. So if you take the square root of both sides, you get absolute value of x minus 2 is less than square root of epsilon. Right? Now this gives you a hint as to what you should take for your delta. This is going to be your delta because see, in the definition, I need absolute value of x minus 2 to be less than delta. So if absolute value of x minus 2 is less than square root of epsilon, then I have this inequality. That's what exactly I want. When absolute value of x minus 2 is less than delta, of course, it has to be greater than 0, then this inequality should hold. Okay, that inequality holds if absolute value of x minus 2 is less than square root of epsilon. Okay, so I take my delta So choose delta to be square root of epsilon. Okay. Now we give the formal proof for this limit state. Okay. So how do we start the formal proof? Given epsilon greater than 0, I take any given epsilon greater than 0. Epsilon greater than 0. Let I take my delta to be square root of epsilon. Then this is what I want to show. If this is true, then I have to show that f of x minus L is less than epsilon. Of course, f of x is this expression and L is 1 in this case. Okay, let's prove that. So let's consider, let's assume that this is true. Okay, the absolute value of x minus 2 greater than 0 and less than delta. Remember, your value of delta is square root of epsilon in this case. If this is true, let's prove that this is true. Okay. All right. I'm going to compute this difference, x squared minus 4x plus 5 minus 1. I'm going to simplify this. This will be x squared minus 4x plus 4, the absolute value of that. This is nothing but x minus 2 squared, the absolute value of that. And now what I can do is I can pull the 2 outside, the square outside, the absolute value of x minus 2 squared. But I know that my delta is square root of lambda, and I know that my absolute value of x minus 2 is smaller than delta. So I can replace this by a bigger thing. To get a bigger quantity, you get, first let me put delta here. Delta squared. Remember, this absolute value of x minus 2 is less than delta. So if I put delta, replace this by delta, I get a bigger quantity. But my delta is square root of epsilon. I can replace this delta by square root of epsilon. That is going to be epsilon then, right? Because if you put a square root of epsilon, when you take the square of that, that should be epsilon. That's what exactly I want. I want f of x minus L, the absolute value of f of x minus L, to be less than epsilon. That's what exactly I have, if this is true. Okay, so that completes the proof. Okay, let's move on. And then we are asked to give the formal definition, formal proofs for each of the following limit statements. Let's work on this. All right, first let's write the formal definition for this limit. Let's work on the first part. What is the formal statement, formal definition for this particular limit? It means for all, this limit means for all epsilon greater than 0, there exists delta greater than 0 such that if x is between 1, 1 plus delta, then the square root of x minus 1 minus 0, the absolute value of that should be less than epsilon. That's the formal definition for this limit statement, right? For all epsilon greater than 0, there exists delta greater than 0 such that if you take your x from this right part of the function neighborhood, remember I take the right part of the function neighborhood because I'm talking about the right limit here as x approaches to 1 on the positive side. Okay, then the absolute value of f of x, this is your f of x minus L, L is 0 in this case, should be less than epsilon. This is the formal statement. So how do you give the proof? Well, again, I start the proof with a given epsilon greater than 0. Given epsilon greater than 0, let or choose delta to be epsilon squared. You will be wondering why I am choosing my delta to be epsilon squared beforehand. How did I know that? Well, I'll that answer the question in the when we compute our absolute value inequality. Okay, so with this choice, I'm going to proceed. Then let's compute this expression here. This inequality. All right, actually, before we compute that inequality, let's make some observations here. What do you mean by x is in this interval, 1, 1 plus delta? That means, let me do some calculation here on a side. X is in that interval means x has to be greater than 1, less than 1 plus delta, right? Now, if you subtract 1 from each term, you get x minus 1 should be greater than 0, less than delta. Okay, with that in mind, let me work with this inequality right here. Pardon me, I'm going to assume that x is in this interval. If x is in this interval, 1, 1 plus delta, then I want to show that the absolute value of square root of x minus 1 minus 0 should be less than epsilon, right? So I know that if x is in this interval, my x minus 1 should be greater than 0 and less than delta. Okay, with that in mind, let me take this inequality, this expression, and simplify that. Okay, so then we have the square root of x minus 1 minus 0. This is equal to absolute value of x minus 1, square root of x minus 1. But now I know that my delta is greater than x minus 1, so I can put a bigger thing here. So this should be square root of delta should be bigger than square root absolute value of square root of x minus 1, right? So now this is where I make my choice. I want to choose my delta so that I get epsilon here, because at the end of the day, I wanted this absolute value to be less than epsilon. This is where I make my choice. Okay, I choose my delta wisely so that when I simplify this whole thing, I get epsilon, because I wanted this absolute value to be less than epsilon. Okay, so by my choice of epsilon, now as you can see, this is square root of epsilon squared, which is epsilon. Okay, so you get absolute value of f of x minus L less than epsilon. That's what you want. This completes the proof. Then let's look at, right, first let's write the formal definition for this limit. This limit means for all epsilon greater than 0, there exists n greater than 0 such that if x is bigger than n, then your f of x or your 1 over x has to be between 0 minus epsilon, 0 plus epsilon. Remember, this should look like this is your L minus epsilon, L plus epsilon. Of course, in this case, your L is 0. Okay. All right. How do we give the formal proof now? Okay. Again, I start with a given epsilon greater than 0. Given epsilon greater than 0, I choose my n to be 1 over epsilon. The reason for this choice will be clear when we do the calculation. Okay. Now assume that, or if x is bigger than n. Remember, if x is bigger than n, 1 over x has to be less than 1 over n. Right? That is clear. If x is bigger than n, 1 over x has to be, the reciprocal has to be less than 1 over n. All right, now we need to show that if x is bigger than n, I want to show this statement. Okay, for that, what I'm going to do is, I'm going to consider this. By the way, what do you mean by this? 1 over x is in the interval 0 minus epsilon 0 plus epsilon. First of all, notice that this is nothing but minus epsilon comma epsilon, right? 0 minus epsilon is epsilon, 0 plus epsilon is epsilon. Pardon me, 0 minus epsilon is minus epsilon, 0 plus epsilon is epsilon. Okay, so this is the interval. What do you mean by 1 over x in this interval? That means 1 over x minus 0 should be less than epsilon, right? That's the absolute value inequality corresponding to this state. Okay, your 1 over x minus epsilon has to be less than epsilon. 1 over x minus 0, the absolute value of 1 over x minus 0 has to be less than epsilon. All right. Okay, so how do we prove that statement? Well, I'm going to consider that difference. The absolute value of 1 over x minus 0. This is equal to absolute value of 1 over x. But I know that 1 over n is bigger than 1 over x. So that means this has to be bigger than 1 over n, the absolute value of 1 over n. But fairly here, I can drop the absolute value actually, because I'm talking about the limit as x goes to infinity. So I want this expression as x approaches to infinity. So now, remember my choice of n, 1 over, the choice of n is, my n is 1 over epsilon. If you put 1 over epsilon here, that is the reason for my choice. Now, if I replace this by 1 over epsilon, then this whole thing will be epsilon. So that is where I make my choice of n, okay? I decided that I have to choose my n to be 1 over epsilon, so that when I simplify this expression, I get epsilon. By the reciprocal rule, this will be epsilon. That's what exactly I want. I want, if x is greater than n, I want the absolute value of 1 over x minus 0 to be less than epsilon, okay? So we have that established here. All right, here is the last example. Again, we need to give the delta-epsilon proof for this limit statement. Again, for this limit statement, let's write the definition. This means, this limit statement means, for all epsilon greater than 0, there exists delta greater than 0, such that if x minus absolute value of x minus 2 is greater than 0 and less than delta, then you should have f of x minus absolute value of f of x minus L less than epsilon. Okay, your f of x is of course 5x to the power 4 minus your L is 80. This has to be less than epsilon. Okay, you need to first have your delta in terms of epsilon. Let's start the formal proof. For a given epsilon greater than 0, any epsilon greater than 0, I'm going to choose my delta to be the minimum of 1 and epsilon over 325. you might be wondering how I came up with this magical thing. I'll tell you how I come up with this thing and why I take the minimum of these two quantities. Okay. So one thing that you can observe is that if you take your delta to be the minimum of these two things, then your x minus 2 has to be less than 1, right? The absolute value of x minus 2 has to be less than 1. So let's start the proof. If absolute value of x minus 2 is greater than 1 and less than delta, let's make some observation here. If your delta is minimum of this 1 and epsilon over 325, then delta has to be less than or equal to 1, right? So that means my x minus 2 has to be less than 1. What does this tell you? This tells you that x minus 2 is between minus 1 and plus 1. Now, if you add 2 to the entire inequality, then you get x is greater than 1 and less than 3. As you can see, if you take your delta to be this quantity, the maximum value of x that you can have is 3. Your x has to be less than 3. Okay. With that in mind, let's proceed with simplifying this statement right here. Okay. So let me simplify that statement. That expression 5x to the power 4 minus 80. The absolute value of 5x to the power 4 minus 80. This is equal to, if you pull out a 5, you get x to the power 4 minus 16. And in fact, if you factorize this, you will get 5 times x minus 2 times x plus 2 times x squared plus 4. That's what you get if you factorize this. Okay. But I know that, I assume that x minus, absolute value of x minus 2 is less than delta. So I can replace this by delta, bigger quantity. Of course, you have to put the absolute value to each individual term. So let me do that first actually. 5 times absolute value of x minus 2 times absolute value of x plus 2 times x squared plus 4. Okay. All right, I'm going to copy this part to the other side. Then you get this. Now, notice that since my x is less than 3, the maximum value that you can have for this piece is when you plug in 3 here, right? You plug in 3 there. 3 plus 2 times 3 squared plus 4 would be 55. Okay, so I have this inequality now. This should be less than 5 times. Of course, I can replace this absolute value of x minus 2 by delta, because I assume that my absolute value of x minus 2 is less than delta. So I should get a bigger quantity. 5 times delta times, I'm going to replace this by the maximum value that you can have when x is less than 3, that is 55. Okay, so this is equal to 5 times 55, which is 325 times delta. But notice that my delta is the minimum of 1 and epsilon over 325. That is the reason for that choice. Okay, the reason that I took the minimum of 1 and epsilon over 325 is I wanted to get an upper bound for this expression. That's why this 1 is sitting there. The reason that this epsilon over 325 is sitting there is that I want to make sure that my delta is less than epsilon over 325, so that I get epsilon when you simplify this expression. I get a bigger quantity when I replace this by epsilon over 325, and I get epsilon. Okay, so this is bigger than 325 times epsilon over 325. Because my epsilon over 325 is bigger than delta. Okay, so now as you can see, we have this cancellation. So you get 5x to the power 4 minus 80, the absolute value of that, less than epsilon. That's what exactly I wanted. I wanted to show that if this is true, I have this inequality. Okay, that's what we have established. All right, with that, we conclude that section. I'll see you next time.